afternoon, friends. Now we have some more problems on the dual of the given primal problem. So here it is on minimization of the objective function subjected to the constraints here. So here, since the objective function is on minimization, so that has to be maximized here. So then we're having the opposite sign for this x2 and x3. We don't have x1 in the objective function. So minus 2x2 minus 5x3. So then subjected to, so then we have minus x1 minus x2 less than or equal to minus 2. So then we'll have here less than or equal to constraint. So that is written as it is. But the third constraint, neither we are having greater than or equal to or less than or equal to, but it is having a equal sign here. So we are writing that x1 minus x2 plus x3, so that is as it is. Now we are using, instead of equal sign, we are having less than or equal to sign now. So the same thing we have written, but instead of equal sign we are writing less than or equal to. But we need to write one more equation for this equality equation. So that is multiply the given equation both sides by minus 1, so that it is converted to less than or equal to. So we are having two equations for this equality equation. So write the equation as it is with less than or equal to constraint, and once again use the same given equation, multiply both sides by minus 1 and use less than or equal to sign. So see here minus x1 it will be, so this minus becomes plus now, plus 3 becomes minus 3, plus 4 becomes minus 4. So x1 x2 x3 greater than or equal to 0. So the given problem was not in canonical form because I have greater than or equal to and equal sign here. So greater than or equal to constraint is converted to less than or equal to by multiplying by both sides by minus 1. So the equal constraint, that equality equation, will be having two equations now in standard canonical form. So first the given problem is rewritten in the standard canonical form. Then the dual of the given problem will be written here as explained in the earlier problem. So since it is on maximization, so the given problem is on minimization, so that has to be maximized. Then we are converting, the same maximization into its duality using minimization function. So ZW. So now having here the coefficient, that is the constants on right side of the constraint. So that is minus 2, 6, 4 and minus 4 here. So minus 2W1 plus 6W2 plus 4W3 minus 4W4. Four constraints are there, 1, 2, 3, 4. So we are introducing four dual variables, W1, W2, W3, W4. Now their coefficients are the constants on the right hand side of the equation. Otherwise, as explained earlier, take the transpose of the given matrix, take the help of it to write the dual of the given primal problem. Then here we have 1, 2, 1 and minus 1. So we are using them here. So that is minus 1, 2, 1 and minus 1. Minus 1, 2, 1 and minus 1 with the variables W1, W2, W3, W4. So that is here it is having less than or equal to. So here we are having greater than or equal to in all the constraints. So then we have to take the second column now. So that is minus 1, 1, minus 1, 1. So that is what is used here with the dual variables w1 to w4 and greater than or equal to minus 2. Then here we don't have x3, so 0, 6, 3, 3, 6, 3, minus 3 we have. So it is 0 w1 plus 6 w2 plus 3 w3 minus 3 w4 are greater than or equal to minus 5, and the dual variables w1 w2 w3 w4 greater than or equal to 0. Then we have one more problem on the writing the dual. So minimization function here subjected to so many constraints here. So all of them are having greater than or equal to sign here. First, minimization function to be maximized. So by multiplying minus 1, so that is rewritten here with minus by multiplying by minus 1. Then all these greater than or equal to constraints are converted to less than or equal to by multiplying both sides by minus 1. So rewritten the constraints by multiplying by minus 1 on both the sides. So having the given coordinates x1, x2, x3 greater than or equal to 0, then we are writing the dual. So how many constraints are there now? 1, 2, 3, 4, 5. So 5 dual variables are having now w1 to w5. Now we are having minus 7, minus 4, 10, minus 10, minus 3 and minus 2 as right hand side constants that we are using in the objective function here. So then in the first column having the coefficients of x1 as minus 3, minus 6, minus 7, uh, minus 1 and minus 4. We are using them here along with the dual variables w1 to w5, and that less than or equal to now becomes greater than or equal to. So with the coefficient C1, C2, C3, that is minus 3, plus 2 and minus 4. So that is the cost coefficients are used in these constraints. Similarly, we are writing our second and third constraint with the dual variables w1 to w5 greater than or equal to 0.